And I understand there was some technical issues with the first one, so here's the new one. Sorry about that, everybody. So this is what we call percent yield. And the operative function is that sometimes things just don't work out like we planned. We spill stuff, we drop stuff, we break stuff. And the reaction that we're looking at here is the reaction to produce iron from iron ore. And the reaction is a pretty straightforward one, where we react iron ore, that's Fe2O3, with carbon monoxide, and it produces carbon dioxide and raw iron. We want to balance this, so I'll make sure that this is balanced. And it looks like a simple process if you are looking at the reaction. I mean, it just simply takes Fe2O3 and reacts with carbon monoxide, and you get iron, and you get carbon dioxide, and so on and so forth. But this is a pretty accurate graphic at what is actually going on in the production of iron. The first step, of course, being right here, this first half right here on the top. And so look at all these steps. We start with our iron ore, our limestone. It goes into a sinter plant and coke ovens. And then to actually make the iron, it has to go into a blast furnace. And then it has to be refined. And I mean, there's lots of steps that go on. And that means that a lot of things can happen. So when we're talking about something called percent yield, what this means is we don't always get what we expect, because stuff happens along the way. Let's try a reaction. Let's say that we have 100 grams of our iron ore. And remember that the reaction looks like this. Iron ore reacts with 3 molecules of carbon monoxide to produce, raw iron and carbon dioxide. So let's ask, if we are going to react 100 grams of iron ore, how much iron should we expect to get? And so according to this balanced equation, we could say, well, how many grams of iron would we get from our 100 grams of iron ore? We know that the mass of 1 mole of iron ore, Fe2O3, is 160 grams in 1 mole. And if we are going from moles of Fe2O3 to moles of iron, the ratio according to the balanced equation is 2 to 1. And finally, if we are going from moles of iron to grams of iron, we know that there are 56 grams. If we bust out our calculator, let's take my little fancy guy right here, and we say, okay, make sure that it's working. Let's say we have 100 grams of our iron ore. We're going to multiply it by 1, which is not necessary, divide it by 160. Let's move this over here so we can all read what I'm doing. Then we're going to multiply this by 2, and then we're going to divide it by 56. How many grams of iron do we expect? I did something weird. Hang on. 100 times 1 divided by 160 times 2 times 56. I think I divided. How many grams of iron do we expect? 70. We expect to get 70 grams of iron. This is what we expect. We're going to call this, make this pen big so you can see this, what we expect. We're going to call this the theoretical yield, because under optimum conditions, in theory, we expect to get 70 grams of iron. But things don't always happen like we expect them to happen. And so let's say that instead of getting 70 grams like we thought, we actually got 50 grams, what we call the actual yield. And what we want to calculate is what percentage of what we thought we were going to get did we actually get? And that is where this comes in, percent yield. It is a simple equation. Percent yield is equal to what we actually got over what we thought we were going to get times 100. So in this reaction, if we thought we were going to get 70 and we actually got 50, what's our percent yield? We're going to say we actually got 50 grams. We thought we were going to get 70 grams times 100. Let's put that into our calculator and see what we get. We thought we were going to get 70. We actually got 50. So 50 divided by 70, and we'll take that answer and we'll multiply it by 100. And we get 71.4%. Not bad. You should know that in industrial chemical reactions, you never get what you thought you were going to get. That's the whole thing. I'm going to ask you to flip this equation around. I'm going to ask you to use it to find actual yield. So we're going to write this a little differently so we can flip it around. If we know that percent yield is equal to actual over theoretical times 100, what would I have to do to get this actual yield to be what we're solving for? So what I like to do is I like to derive these. Well, if we're dividing by actual on this side, we would take, if we're dividing by theoretical, we would take our theoretical and multiply this on the top and then divide both things by 100. So the version for finding actual yield looks like this. We're going to say percent yield times theoretical divided by 100. Let's try that on this one because we knew our percent yield was 71.4 and we knew our theoretical was 70. So let's see if we get our actual yield of 50 if we plug this in the other way. So if we have a percent yield 71.4 and a theoretical yield of 70 grams and we divide this by 100, do we get the 50 that was our actual yield? And let's try this on our calculator. And so we're going to say 71.4 times 70. We'll take this answer and divide it by 100. Do we get the 50 that was our actual yield? Close enough. Our actual yield is 50 grams. Okay, I apologize for the technical issues, and everybody have a nice afternoon.